All right, welcome. In this video, we're going to be working the Algebra 2 Unit 3 review. And I need a pen to work with. But this is all about absolute values. So we're going to solve some absolute value equations, we're going to solve some absolute value inequalities, and we're going to do some absolute value graphs. Okay. And before I even start, hopefully at this point you have already reviewed your quizzes, because those are actually the best thing you can use to review for the test, right? This is just more practice of things that you need more practice on, right? And it's good that we do it, but the best thing we can do to prepare, once again, is review our quizzes. Okay, now that I've done that, a few seconds in, let's get to it, okay? First step, always isolate the absolute value. And I'm going to work this on a separate sheet of paper because I know I write big, so I need to give myself some room to work. So I multiply both sides of this equation by 8, and I get absolute value of 7p plus 4 equals 12. And if the absolute value of a number equals 12, then the number is either 12 or negative 12. So 7p plus 4 is either equal to 12, or 7p plus 4 equals negative 12. I'm going to subtract 4 from both sides of both equations. It would be 7p equals 8, 7p equals negative 16, divide by 7, p equals 8 sevenths, p equals negative 16 sevenths. Okay, easy enough. Okay, this one's going to be very similar. So we're going to, move that work out of the way. Okay. I'm going to start by subtracting 3 from both sides. So the negative absolute value of 8x minus 6 is equal to 0. Okay, well that just means the absolute value of 8x minus 6 is equal to 0. Make sure to put one of these on the review because I didn't put one of these on the homework. Okay, if the absolute value of a number is 0, the number has to be 0. Okay, so that just means 8x minus 6 needs to equal 0. And 8x equals 6, and x is 6 over 8, which we could reduce to 3/4 if we needed to. Okay. Now, the next couple of them, let's see where we're going in the future, doing some graphs. All right, so I'm going to start by subtracting 2 from both sides, so I'll have negative 5, absolute value of 5m minus 5 equals, when I subtract 2 from negative 73, I'll have negative 75. Now, if I divide by 5, okay, that'll be positive 15, because 75 divided by 5 is 15. If the absolute value of a number is 15, then that number is either 15, or maybe that number is negative 15. Okay, so I'll add 5 to both sides of both equations. Negative 15 plus 5 would be negative 10. And divide by 5. And I got myself 2 solutions. Okay, and those are the 2 solutions to that equation. All right, and I didn't say it out loud. I have been mentally checking at the end of each problem that I'm not in a potential extraneous solution situation where I've got x's on the or variables on the inside and the outside of the absolute value. Okay, so I'm going to start by adding 9 to both sides. So 57 plus 9 is going to be 66. So 6 times the absolute value of 1 minus 5x equals 66. And then I divide both sides by 6, and I see the absolute value of 1 minus 5x needs to equal 11. Then, if the absolute value of a number is 11, then that number is either 11 or that number is negative 11. Right? Then I'm going to subtract 1 from both sides. Negative 5x equals negative 12. Negative 11 minus another 1, that would be negative 12. And then I'm going to divide both sides by negative 5. X equals negative 2, and x equals 12/5. Okay, those are perfectly fine answers. All right, and then the next couple, let's see, now a sheet of paper, or I can just fold this one over, I guess. All right, here I'm going to isolate the absolute value, add 3 to both sides, divide by 3. Okay, if the absolute value of a number is equal to 7, then that number is either 7 or it's negative 7. Okay, subtract 3. So 7 minus 3 is 4. No, I'm subtracting of negative 5r equals negative 10. And then when I divide both sides by negative 5, I'll have, okay, r is negative 4/5, or maybe r is equal to positive 2. Okay, and again, r is only on the inside of the absolute value, so I don't need to worry about extraneous solutions. All right, over here, 5 times the absolute value minus 7 equals 38. I'm going to start by adding 7. dividing by 5. And then, okay, if the absolute value of a number is 5, then the number is either 5 or negative 5. So 9 minus 5n equals, I'm going to do something different this time because I've been doing these problems the exact same way every time, and hopefully you're like, okay, dude, I get it at this point. I'm going to call this plus or minus 5. Okay, and then I'm going to subtract 9 from both sides. And so I'm just going to say negative 9 plus or minus 5. So I know that's either negative 4 or negative 14. Okay, and then n equals negative 9 plus or minus 5 divided by negative 5. Okay, now that's not good enough. That's not good enough to be an answer for us. But what we can do is we can say negative 9 minus 5 would be negative 14 over negative 5. N could be 14 over 5 because negative over negative is positive. Or if this was plus, I'd have negative 9 plus 5 is negative 4 over negative 5. That would be where n is 4/5, right? You can do this. You can do the plus minus thing if you like, right? Some people, that's how they solve absolute value equations. And like I've said a bunch of times in my class so far, if you are solving these problems in a way that is, if you're solving and you're correct and mathematically justified, well, you're going to get the credit. Right? Okay, number 2, solve the inequality. All right, lots of inequalities. That's good. 6 of them. All right, hopefully I've got a good collection. All right, so we're going to add, just like with the equations, we isolate the absolute value, so I'm going to add 1 to both sides. I might use a capital B so I don't get confused with 6. That'll be 74. Okay, if I divide 74 by 2, that's going to be a little bit bigger than 35. That would be 37. Okay, so if the absolute value of a number is bigger than 37, it's all about 37 and negative 37, where the absolute value is bigger is over here, and over here where x is more negative, or when a number is more negative than negative 37. Okay, so that means that this thing on the inside, this number, 10b plus 7, needs to be greater than 37, or maybe 10b plus 7 is more negative than negative 37. All right, and then I'm going to go over here and just start subtracting, dividing by 10. Okay, and then over here, 10b less than, if I subtracted 7 from negative 37, I'd get negative 44. And I could divide by 10 and get negative 4.4. It's an option. Okay. And I feel like I had something more to say about this. Oh, if I needed to write these as intervals, okay, this is over here going back to negative infinity. This is the lower one. I'm going to write it first, negative infinity up to negative 4.4. Okay, parentheses because this is a strict inequality, and always parentheses around infinity because infinity is not a real number. Union 3 to positive infinity. Okay. For number 7. There we go. So I'm going to subtract 7 from both sides. So the absolute value of 6v plus 7 less than or equal to 63. And, right, just making sure. Nope, not 63. That's going to be 53. I was like, that doesn't look like it's going to work out quite right, like I expect it to. So, all right, if the absolute value of a number is less than or equal to 53, that's going to be between negative 53 and positive 53. So I know that this thing here needs to be between negative 53 and positive 53. Okay, then I'll subtract 7. All right, 53 minus 7 feels like 46 to me. Let me think about that. 46 plus 7, yeah, that's going to be 53. All right, and I'm going to divide everything by 6, and I'll get negative 10 to 46 over 6. Okay, and that's, I'm sure you could simplify that if you needed to, but I'm just not going to. I don't feel like I need to. All right, and I was covering up the original problem, but there you see it. All right, let's do 2 more. completely, and all right. Now I'm going to subtract 8 from both sides, so I'll have less than or equal to 16, and I'll be left with 4 absolute value of 6 minus 2a's. All right, then I'm going to divide both sides by 4, and I'll get absolute value of 6 minus 2a is less than or equal to 4. And I think about, okay, where's the absolute value of a number less than or equal to 4? Well, it's equal to 4 over here at negative 4 and positive 4, and the absolute value is less in here in the middle. And let's see. Oh, yeah, so 6 minus 2a, this number whose absolute value is less than or equal to 4, it's going to be stuck between negative 4 and 4. So I'm going to subtract 6, and then I'm going to divide both sides of both inequalities by negative 2, but remember that's going to reverse the direction of our inequality. So negative 10 divided by negative 2, that's positive 5. I have 1a. Negative 2 divided by negative 2 is 1. Okay, and like you could stop here if you were just giving an inequality, but in multiple choice, we're going to write these with the lower number below, because that's pretty standard. And if we were going to write this as an interval, we have to write the lesser number on the left. Okay, so I wouldn't want you to give me 5, 1 as an interval, is what I'm saying, right? Okay, but I think that's enough for that problem. All right, I'm going to start by subtracting 6 from 51, and that will be 45. I'm going to divide both sides by 9. And then I'm going to say, all right, when is the absolute value of a number greater than 5? Okay, well, definitely when when the number is greater than 5, but also when the number is more negative than negative 5. Okay, so this 3n minus 2, it could be less than negative 5. Or 3n minus 2 could be greater than positive 5. Right there. Then I could add 2 to both sides of both inequalities and then divide by 3 on both of them. And there I've got myself an answer. Okay, I'm going to write these as an interval as well, so negative infinity up to negative 1. Okay, not including, because of the strict inequality, union 7/3 up to always parenthesis around the infinities, never square brackets. All right, 2 more inequalities. I think that hopefully one of these is going to come back like, one of the special cases like no solution, infinitely many solutions. And speaking of special cases, you need to not forget about those really, really fringe ones like absolute value of x is less than or equal to 0, or absolute value of x is greater than 0. Don't forget about those also, because they might not be on the test. They were on your quizzes, and might not be in your review, but they were on the quizzes and they were on the notes and the homework. So I would say it's probably a safe bet to think they're going to be on the test too. Okay. All right. So first thing we're going to do here is start subtracting 3. Negative 89 minus 3 more is negative 92. Okay. And then I'm going to divide both sides by 4. Does 4 divide 92? Doesn't feel like it, but maybe it does. What would it be? Oh, yeah, it's going to. Okay, so 4 times 20 is 80. So that would be 4 times 23. Okay, that's not an arithmetic I'm familiar with, but it's all good. Figured it out. And think, okay, when is the absolute value of a number greater than or equal to negative 23? Always. Absolute value is always either positive or 0, so that's always greater than or equal to negative 23. I'm going to say that this inequality is true for all real numbers. Okay. And then over here, I'm going to add 3. So 9 times the absolute value of 1 plus 8n is greater than or equal to 81. And I divide both sides by 9. 1 plus 8n's absolute value is greater than or equal to 9. And, okay, this is not a special one, but this is a more typical one. And it's probably good that we practice those even more. Okay, so the absolute value of a number can be bigger than 9 when it's bigger than 9 or more negative than negative 9. So I'm going to say, all right, 1 plus 8n might be less than negative 9, or maybe 1 plus 8n is greater than positive 9. Okay? And then I could subtract 1 from both sides of these inequalities. and then divide by 8. Throw a little or in there. Wait, I lost track. I did this once earlier today when I was making a quiz key. I lost track of a less than or, yeah, like the or equal to part. And you don't want to do that. Okay, so if we're going to do this, then our solution region is going to be, all right, negative, if we want to write this as an interval, negative infinity up to negative 10/8, which I can call negative 5/4, square bracket because less than or equal to, union 1 to infinity. Okay, again, square bracket because less than or equal to. Okay, that was all of the absolute value inequalities. Okay, I'm going to do, you know, the next couple of pages, and I guess to you it's just going to be in a second, but I've got a calculus class about to come in, and so I'm gonna stop for now and then just resume on this, I guess, after that. All right, I'm back. That was a pretty intense calculus class. Lots of problems. Lots of questions. And so, all right, we're back here. We're sketching some graphs. Oh, we can do that. All right, so first order of business, find the x value of the vertex. So to find the vertex, I'm going to say take the inside of the absolute value and set it equal to 0. Okay, and then we're going to say, all right, that's 2x equals 3 and x equals 3/2. Okay, the y-coordinate that corresponds to x equals 3/2 is going to be 2 times the absolute value of, when I double 3/2, I get 3 minus 3, that's 0. 2 times the absolute value of 0, that's going to be 0. Okay, so x equals 3/2 and y equals 0. Okay, 3/2, that's not ideal, but I guess we could probably work with that. Let's go over here and let's choose for my other point. I'm going to choose x equals 0. I always choose x equals 0. It's easy to do arithmetic with. So I'll have y equaling 2 times the absolute value of 2 times 0. Okay, that's going to be 0 minus 3. So 2 times positive 3 equals 6. So 0, 6. So if I went 1.5 to the left and I was at 6, using the symmetry, I should be able to go 1.5 to the right and also be at 6. I'm just going to kind of... This is a sketch. Okay, and that's definitely a good sketch. All right, this one, I know that this is a little troublesome. Now, maybe I'll say a little bit more about this. This is going to be not a very good graph. I can just tell you. The slope is way too steep. We would need this to be like -5 or something for us to even really be able to see what's going on here, but I'm not going to change the problem. I'm going to say, all right, x-coordinate of the vertex, we're going to find by taking the inside and setting it equal to 0. So negative 3x equals positive 3 when I add 3 to both sides. And I divide by negative 3, and I get x equals -1. The y-coordinate is going to be 3 times the absolute value of, okay, so negative 3 times -1 is 3, minus 3 is 0. Okay, so that's going to be 0. So x equals -1, y equals 0. Okay, and then one other point. Okay, my other point, I'm going to choose x equals 0. So x equals 0 and y equals 3 times the absolute value of, okay, that'll all be 0 minus 3. Okay, that's 3 times 3, that's equal to 9. 9 is not on my thing, so I'm just going to say it's right there, and then, okay, I'm going to go over 1 the other way, and it's going to be right there, and okay, that's the best I can do. Okay, you see that that's a little rough. Okay, but you know, what else can I do? That's going to be a good enough sketch for us. That's supposed to be 2 line segments, but yeah, whatever, let's just move on. All right, so here we've got, uh-oh, that's not good. I was trying to silence my phone, but it seemed like they silenced it for me. All right, so I've got here, I need to find the vertex. So I've got negative 3x plus 4 equals 0. Really interesting. I'm surprised that this was for my extra practice. I thought CUDA software typically tried to stick to whole number, especially in graphing. Whatever. So maybe I'll add 3x to both sides. I usually wouldn't do this, but you know, it's going to be the same. I'll divide both sides by 3, and I get 4/3. Okay, so that's 1 1/3. Oh, well, I don't know. That's not going to be the y location. I just was making assumptions I should not have been. Okay, so we just put that there. No harm, no foul. All right, so then the y-coordinate is going to be 2 times the absolute value of, when I put in 4/3 there, I better be taking the absolute value of 0. That's what causes the vertex in the first place. Minus 3, so I've got y equals -3. So 4/3 and -3. All right, and let's see, 4/3, goodness. I'm just going to choose x equals 0 for my other point. And that's going to be x equals 0, y equals 2 times 0 plus 4 is absolute value, so 2 times the absolute value of 4 minus 3, so that's 8 minus 3 is 5. All right, now this is a little tricky because I went to the left by 4/3 and I'm going to need to go to the right by 4/3. So it's going to be 8/3, which feels like 2 and 2/3 right there. Okay, but just, you know, maybe you are already thinking like, yeah, he wouldn't put that on the test. And I definitely would not, right? Not interested in that. Okay, what else do we got here? All right. Okay. All right, this is just more of the same. Take the inside and say negative 2x plus 4 equals 0. Okay, and it's going to be to get my vertex. I'll put that in. I usually write that out. Finding the vertex there. That's going to be 4 equaling 2x, and then 4 divided by 2 is 2 equals x. Okay, I can find the y coordinate by saying that's negative 3 times the absolute value of when x is 2. I've got negative 4 plus 4 is 0. Okay, that's good. That's what causes a vertex. Good confirmation. Plus 3 is equal to 3. Okay, so x is 2, y is 3. And then we're going to choose another point. How about x equals 0? Oh, good. We had one that opened downward. I was kind of concerned that that wasn't going to come up on the review. Okay, so another point is going to be x equals 0 and y equals negative 3 times the absolute value of 0 plus 4 plus 3. Oh, no. That's going to be off the negative 12 plus 3 is negative 9. That's not on my grid. What a shame. I guess I should have done x equals 1. Okay, I'll try that. I've got plenty of paper, plenty of room. So x equals 1. And y is equal to negative 3 times negative 2 plus 4, that would be positive 2, plus 3. Okay, so I've got negative 6 plus 3 is negative 3, so x equals 1, y equals negative 3. So I go over 1, and I end up down here. I go over 1 the other way, I should end up down here again. Okay. And so when that number that's getting multiplied on the outside by the absolute value is negative, that's going to cause the v to open downwards, and it'll be flipped upside down. Okay, but I think that's all I've got to say about that. All right, solve the equation by graphing. So I'm going to bring out a couple of colors here, and I'm going to graph. So first I might graph the equation y equals negative 4/3 x. I'll graph that one in red. Okay. Now, that should go down 4 when I go over 3. So I'm going to just kind of keep going over by 3 and down by 4. 9, negative 12. And then I can go back this way as well. So 3 this way, 4 that way. 3 here, up to 8. Okay. When x is 9, x is negative 9, y should be 12. Okay, and that's a set of points, right? We could connect the dots, and actually I probably will. So, okay. In my class, we oftentimes realized that, okay, if we were going to solve by graphing, presumably the answer is going to be at a grid intersection spot. We really only need to plot the points that go through grid intersection spots. But I think, you know, it's best for us to just graph the whole thing. So 4x plus 16, I'm going to graph y equals absolute value of 4x plus 16. I didn't really leave myself enough room, but I can just go over here and say I'm going to compute the vertex. And that's going to be where 4x plus 16 equals 0. Okay, so 4x equaling negative 16, x equaling negative 4. Okay, the y coordinate that goes along with that is the absolute value of negative 16 plus 16. That's the absolute value of 0. That's going to be 0. So I go over here to where x is negative 4 and y is 0. And then I'm going to choose another x value, like, well, I probably shouldn't choose x equals 0 because then that's going to come back with y equals 16, right? And I don't have 16 on my graph, unfortunately. I'm going to need to choose maybe x equals, let's do negative 3. I feel good about x equals negative 3. so that y equals the absolute value of 4 times negative 3 is negative 12 plus 16 is the absolute value of 4. So negative 3, positive 4. Oh, look, I found a solution. So if I went over to the right and I was at 4, over 1 to the right and I was at 4, I should be able to go over to 1 to the left and still be at 4 because of the symmetry of these graphs. And then I'm going to extend that line, and I'm going to say, oh, I found another one. There we go. All right, great, good for us. I may have messed that up. Yeah, that was supposed to be through that point. There. Okay, yeah, pardon me. But what is mattering really is the intersection points, and really the x-coordinate of the intersection point, because that'll be the x value that makes these equations true. So this is x equals negative 3. And right there, x equals negative 6. Okay, yeah. And that's how we solve by graphing. I know I've got some more stuff on the back. I'm trying to remember what it was. Oh, yes, just some questions that, I don't know, hopefully they'll seem familiar when you get confronted with them on the test. All right, so let f and g be these two functions that we're defining right here. Where is f of x equal to g of x? Okay, well, we've got expressions for each of these. So we're going to say, I might just start with f of x equals g of x. Okay, so that would be 4 plus the absolute value of x minus 5 equaling the absolute value of 1/3 x plus 2 plus 4. Okay, so I'm going to subtract 4 from both sides. Okay, this would not work otherwise. We don't solve equations like this. Okay, we just don't. Not that you can't solve them, it's just that we believe that solving equations of this variety is beyond the scope of Texas Algebra 2. So what we're going to do is we're going to subtract 4 from both sides, and so these will be gone. And one thing we do try to solve in Texas Algebra 2 is absolute value equals absolute value, right? So we're going to say if two absolute values are equal, then it's the case that they're just exactly the same. Or they could be off by a factor of -1. One could be the negative of the other. So I could say x minus 5 is the negative of 1/3 of x plus 2. Okay, either way, I'm going to subtract 1/3 of x. Actually, maybe I'll add 5 first. Okay, if I subtract 1/3 of x, this is 1x. That's 3/3 of x minus 1/3 of x is 2/3 of x. Okay, now I can multiply both sides by 3. I'm going to have to allow myself more room to work here. So 2x would be 21. X would be 21 divided by 2. You can check this equation, and okay, I can see that it's going to be true, and or at least on a positive. It's not. You're not going to. That's what I'm saying. Okay, now over here, this would be where x minus 5 is negative 1/3 x plus 2. So I'm going to need to, I guess, add 5 to both sides. Okay, but this is 1x, so that's 3/3 x, and when I add a third, I'm going to have 4/3 of x, equaling 7. Okay, so now I'm going to multiply both sides by 3. That was 4x equals 21. Divide both sides by 4, and I get 21 over 4. Wait a second. Hold on. Oh, that's weird. Okay, did not expect that to happen. Hold on, let me just check and make sure that's right. Nope, that was definitely not right, because when I distributed that negative, I forgot to make this negative, so this would become a negative, and that's, wait, no, but hold on. Now, okay, this is where the difference is. So when I add 5 to -2, I'm going to get positive 3. 4/3 x equals 3, so I'm multiplying both sides by 3 and getting 9, and then that would become 9/4. Okay, pardon me, I hope to avoid an error like that on this video, but you know I'm not about to just re-record, right, because it's Friday and I'm about to go home, so I think that will be all. X equals 9/4 and x equals 21/2. Okay, that's a more reasonable solution. It doesn't include any errors. All right, part B, find the x-intercept on the graph of G. Okay, well, we just would need G for that. Okay, so for an x-intercept, that's a point where y is equal to 0. Okay, so we're just going to say g of x represents y, so that's going to be g of x equals 0. Absolute value of 1/3 x plus 2 plus 4 equals 0. Okay, now let's isolate the absolute value. Okay. And if the absolute value equals a negative number, you know that that has no solution. And so I would say that it has no x-intercepts. What else? Oh, the other thing I was going to say about this is if you wanted to graph g of x, you could produce a sketch of it, and you would see that it has no x-intercepts because its vertex is above the x-axis, and it opens upwards. So it somehow looks like that. I'm not going to commit to any sort of y-axis or scale, but I know that there's not going to be any x-intercepts because of, well, it looking like that. Okay. That's good. Part C, find the y-intercept on the graph of f. Okay. All of these absolute value functions will have a y-intercept because a y-intercept, I'm going to scoot that down so we can see f. A y-intercept is just where x is equal to 0. So we're going to plug in x equals 0. Okay, and we're going to plug in 0 to f, and so we'll have f of 0 equals 4 plus the absolute value of 0 minus 5. Okay, the absolute value of negative 5 is positive 5, so I've got 4 plus 5, and that's going to be 9. So my y-intercept is the point where x is 0 and y is 9. Okay, got 3 more parts of this one. Right, part D, at what values of x, if any, does f of x equal 3? Okay, I'm going to just copy that problem and then just leave f of x over here. I've already forgotten, I've worked too many algebra problems today. F of x equals 3, so I'm going to substitute for f of x 4 plus the absolute value of x minus 5 equals 3. I definitely did not mean for this to happen. Make sure. That's a shame. Okay, it's going to be another no solution, but, you know, we didn't run into that in the kind of drill problems in the first page, so I guess it's good that we are really hammering home that if you subtract 4 from both sides and you get absolute value equals negative number, that has no solution, so it never equals 3. Okay, so I would just say f of x equals 3 for no values of x, or that never happens, or something like that. Then E, when is g of x greater than 6? All right, g greater than 6. Okay, so 1/3 x plus 2 plus 4 greater than 6. So we're going to isolate the absolute value. Okay, and then if a number is bigger than 2, or the absolute value of a number is bigger than 2, then either the number is greater than positive 2 or it's more negative than negative 2. Okay, so over here, I'm going to say, all right, this thing on the inside, this number, it's either less than negative 2 or 1/3 of x plus 2 is greater than positive 2. And we can solve these separately. 1/3 of x, I'm going to subtract 2 over here, and I'll have negative 4. Triple both sides, multiply by 3. Multiplying by positive 3, that won't change the direction of the inequality. 1/3 x greater than 0, multiplied by 3, does not change the direction of the inequality. And I've got these two things. Either x is less than negative 12, or x is greater than 0. So if I needed to write that as an interval, that would be negative infinity up to negative 12, not including negative 12, union 0 to infinity. Okay, not including 0, definitely not including either infinity, because infinity is not a real number, right? So we're not going to have x equaling that. Okay, that was almost the last one, but I've run out of space over here, so maybe I'll just work this one right here. When is f of x less than 3? Okay, I feel like that's going to be never, but I'll show you why algebraically. Less than 3. All right, so I would subtract 4 from both sides, and I get absolute value of x minus 5 less than negative 1. And I think about where is the absolute value of a number less than negative 1? Well, the absolute value of a number is either 0 or positive. It's never negative, and it's definitely never less than negative 1. So I'm going to say never. And that would be no values of x would satisfy that inequality. And I think it's good because I know we didn't see enough of the kind of the special cases of inequalities in this review. Okay, this was a good set of review problems. I appreciate you watching. I really hope this helped. But I just want to reiterate once again that, you know, if you're reviewing for an upcoming test or something, the best thing that you can do is go back and work those quizzes, look at the problems that you missed, print out the other form of the quizzes, and check the solutions to those quizzes, and that will help you study for the test. All right, that's all I've got. Thanks for watching.